Hello everyone. My name is Agastasya Dahiya and I'm an undergraduate student at Bennett University. I have done this work of hand gesture recognition with one of my friends and other faculty members, uh, Dr. Rohan, Katti, and Luigi from Bennett University and Cambridge, respectively. So, hand gesture recognition are one of the most intuitive and universal forms of interacting with technology. For example, waving a hand at someone can be a simple gesture of communicating with, for example, this laptop or a projector. Uh, by using this hand gesture technology, the need of physical devices like keyboards, mouses is they are not required anymore. How do we achieve this? The application of I'm sorry, the application of hand gesture recognition could be in healthcare. For example, it could help disabled people or people with limited mobility uh, interact with their environment. It can be used for gaming purposes in virtual reality and augmented reality. Interacting with home appliances, for example, or industrial automation can be other example. So, uh, how do we achieve hand gesture recognition? A few of techniques are camera-based recognition, in which gestures are detected by image processing. Markerless tracking eliminates the use of any wearable devices. But the limitation of this approach is privacy concerns, lighting, and we cannot have a camera with us all the time. So if we are, for example, walking outside. Uh, Other technique is using EMG sensors. And these electrodes are placed on our forearm to detect the muscle activity. And based on that, we can detect what type of gesture has been performed. This technique is very useful for precise uh, hand movements like moving our fingers. But the limitation of this approach is we can only detect the gestures which involve finger movement, not the broader arm movement like waving or swiping. Additionally, some noise uh, can affect the recognition. So to address these challenges, my work is on using IMU sensors. In this, we measure the acceleration and orientation of the arm using an accelerometer and gyroscope. This method is unaffected by the lighting or any visual obstructions, and we don't require any precise placement of the electrodes in case of EMGs. So for this work, I have used ST Microelectronics Discovery Board. It consisted of multiple different sensors which were not used for this research, only the onboard microcontroller and IMU sensor. The accelerometer was capturing the XYZ axis for the acceleration and gyroscope for the angular velocity of the orientation. For this, we have collected 300 samples for each of the 7 gestures, namely swiping right and left, clenching, tap, rest, ideal, and wake up position. Each gesture was collected over 340 millisecond at a rate of 200 hertz. The collected data was in a matrix form, 6-dimensional matrix, and the column values were XYZ for accelerometer and XYZ for gyroscope. Uh, uh, After collecting the data, a low pass Butterworth filter was applied to remove any noise and normalize so that uh, machine learning model can be trained effectively. Data from the CSV file was passed into the convolutional network with the 6 layers. Uh, the first, each layer had 68 filters and the kernel size was 8. And after the convolutional layers, the the matrix was flattened and then passed to the uh, softmax activation function so that we can have a probability distribution of how much of the gesture of which gesture is detected. Uh, based We studied 6 different machine learning models for this. The one-dimensional convolution network for 3 different layers, 2, 6, and 12, recurrent neural network, and long short-term memory models. Based on the results, we can see the one-dimensional convolution network with 12 layers performed the best with 99.29% of accuracy, but it had a lot of memory usage uh, for our model for our database. So we end up choosing the 6-layer network because of its memory usage and the time it took to predict which gesture was recognized. This is the confusion matrix for the one-dimensional model, the one we chose. As you can see, almost every gesture was predicted 100% of the time, exception being the swiping and wake up gesture. So to conclude this work, we can say this approach is very useful for especially for the people who have amputations, for example, because in that case, other approaches like EMG and camera-based are not really used because you cannot have finger movement because of the prosthetic arm you have. So this approach of IMU sensors is very useful in this case. The future work of this research involves miniaturizing the device so that it could be like a wristwatch size and testing it on the patients and outside world. That was it. Thank you very much.